Good afternoon. My name is Robert Bankston, KE4AL. I am the president of AMSAT, more formally known as the Radio Amateur Satellite Corporation. We are a nonprofit established in 1969, March 3rd, I believe, with the sole purpose of putting amateur radio in space. And to do that, of course, we have to design, build, and launch satellites. We also work towards promoting space education for both adults and for youth. So today we've got several people that are going to speak. Our Vice President of Engineering, Jerry Buxton, N0JY. Frank Karnauskas is going to talk to you about our new youth initiative, N1UW, is that it? Oh, the number one usually wins. Okay. We'll see how that one works. And then Alan Johnston is going to be speaking about education. And then at the tail end, we've got a special guest, Nick Pugh, will be sharing some information and news about upcoming events. So with that, I will turn over the microphone, but before I do that, let me, a couple admin things. Number one, just like ARIS, AMSAT is always in need of volunteers. So we're a volunteer organization. Nothing gets done unless people volunteer to do it. People say, when are you going to do X? And I say, well, when I got somebody who wants to volunteer to do X. So if you'd like to join us and help us do something, maybe you have a personal goal, please come by the booth, talk to me. I'll be happy to help you get started. Second thing is I have, we used to have an office in Washington, D.C., and I closed that with Martha's retirement in 2020. And that left me with a lot of excess inventory, of which I have some 2015 polo shirts. They're light blue, so yeah, 2015. No, it started out about 2000, and I've been dragging those things all across the United States for a couple of years. But they are going to be free for anyone that wants one at our booth following this forum presentation. So there's limited quantity, limited sizes, but swing by. We'd love the opportunity to talk to you, and you get a free shirt in the process there. I believe they are related to, in 2015, we were going to launch 2 Foxes, so it says 2 Foxes in 2015, I believe, on it, but it's got the AMSAT logo. All right, thank you very much. And now I'll turn over the floor to Jerry. We are in building 1, so right across the Carnival Way there, and we're in the far back corner. So we've got the far back corner is ours, and then we also have an outside satellite demonstration area. Love to meet you.
With free shirts, I'm sure a lot of people love to meet you too. Jerry Buxton, Vice President of Engineering, good afternoon. I'm going to give a short overview of what's going on in engineering and there are a lot of exciting things that are taking place. Jonathan Brandenburg, Assistant Vice President of Engineering, would be here. He's not here, so I will also be speaking on his behalf for Fox. I usually let him talk about that for Fox Plus. With the Golf T program, the Golf T satellite specifically, we are still targeting a launch for 2025, and that is a NASA Alana launch, and that was selected back in 2018. The 550 to 550 kilometer circular orbit is what we've asked for. You have to request an orbit, but as a matter of fact, with Golf T, we want to be up that high. The inclination doesn't matter as much, but the whole thing behind the idea of Golf T, the technology exploration environment, is to test out the new technology that we're flying with it to carry forth with. Excuse me. That is the deployable solar panel array, and that's something that's an in-house design. AMSAT, you may know, has traditionally designed a lot of our own spacecraft from the frame on up, and this is one of those things that we're looking for. And it saves a lot of money. It gives us more flexibility in what we want to do because we can design it to our needs. And we're going to need more power capability as we go for higher orbits, as we add more robust radios and such to the satellites. So more solar panels is going to be necessary. We're also going to fly the AMSAT radiation tolerant IHU. This is an internal housekeeping unit, which is the CPU or the computer for the satellite. This was developed as part of our ASCENT program, and the radiation tolerant IHU is kind of an intermediate step into radiation between the LEO orbits and the HEO orbits, where you need to get into rad hard such stuff. The radiation tolerant is expected to be able to mitigate upsets and latch ups because it has two processors that are operating in tandem. And we can explain more about that at the table. And we're going to get our first knowledge and experience with an ADCS, which is an attitude determination control system. That's going to be key for what we do, and especially with new orbital debris regulations from now on, to be able to not only point the satellite for our own reasons, to get more sun, to get good pictures, to get good antenna pointing, but for future deorbiting and to satisfy those rules. We're flying an SDR, which is the EDIS 310 in this case, to learn and work with the capability of flying SDRs on future missions. Of course, they give you a lot more flexibility in what you do with your radio versus having a specifically, such as the Foxes did, dedicated channel and dedicated mode of operation. And the SDR is going to be providing a microwave downlink, which is part of what we're experimenting with. We want to look for high-speed data downlink, as customers, which would be our STEM experiments, are looking more and more to have more data and faster data, since we fly them, as part of our educational outreach, that we want to be able to make sure that we also bring back the science that they're up there to look for. And the microwave band specifically, with this X-band downlink, is going to be necessary as we move farther out with the orbits, because with more gain, it's at the higher frequencies, it's a lot easier to achieve than it is with 2 meters, 70 centimeters, for example. Golf 1 was also selected in the CSLI selection in 2018. It's targeted for launch in 2026, about a year behind Golf T, and it'll go to about the same orbit right now because of the way orbital debris rules are. Until we understand more and are able to comply with FCC's regulations, we will, I'm going to say it's going there. I'm looking for higher, but right now that's the only thing I can guarantee, if you will. And this is going to be a full flight. We intended, Golf T to be the let's test things out. So assuming that they all work well or we learn enough lessons from them, then Golf 1 is going to be essentially the same with the same deployable panels and such, but it will also carry more STEM experiments. We have a high school is interested in flying a camera, and that is part of the entire package that we submit to NASA to get the launch. And we'll be working on advancements as well with this. In the lessons learned from Golf T, even if it's in development and it's not up in orbit that long before Golf 1. We did that with Foxes. We learned as we went along. We just did not ever have time to make any substantial adjustments to the following ones because of the demand and the launch schedule for those. So this will give us an opportunity to improve even more as we proceed with the Golf program. And the attitude control is something that we need to keep studying and maneuvering and practicing with, because it becomes really critical when you are going to use propulsion. When you are going to point yourself somewhere in an orbit and change your orbit, you have to be extremely precise, because you might try to move out of the way, for example, of collision avoidance, which is what part of the FCC rules are concerned with. But if you don't go where you wanted to go, you're likely to cause more collisions to avoid. I want to be sure with us, because we've not done it with CubeSats before. We've done it with previous satellites, but that we are a good citizen up there as well as we have been, and stay out of everybody's way and for everybody's good. And then we're going to increase the use of the microwaves. This does not exclude VHF and UHF, but it is there to give everybody the opportunity to learn and practice and start to get involved with the microwave. And that would include uplinks on possibly 1.2 or 2.4 gigahertz and an uplink on C-band, 5 megahertz, which is part of the 5 and dime idea. And the downlink continues at 10 gigahertz for the X-band. Onto the Fox Plus program, and here's just a brief overview of what it is, since it's rather new. This is a continuation of Fox in a sense. It's a series of 1U satellites building on what Fox 1 had done. We're looking to be able to have more frequent launches with the Golf, especially because it's all new design and it's testing out this new stuff and it needs to be built. It takes longer to get there. The Golf can be launched even from ISS, for example, and other opportunities that are becoming very abundant for LEO flights. So that should be able to give us an opportunity to have a greater continued presence with such satellites.
Hey, Jared.
Yep.
You said golf a couple of times instead of Fox? You sure you want that?
I'm sorry. On this slide?
Yeah.
Okay. I'll start again real quick. Frequent launches to maintain easy access presence as the Foxes did. They were very popular, and that's what we're looking to go with this. And that's why it's called Fox Plus. And we're also going to expect to be able to do some rapid flight testing of new systems. So as we develop new stuff for Golf and Fox, we can take that and get it into orbit quicker to test it and see, you know, is it ready for prime time, or do we want to do some more work on it? And a lot of that stuff will be coming from what's developed in ASCENT, and I'll talk about that in a moment. And with Fox and Golf, we expect to be able to share the designs or techniques because the footprint's the same for the stack, essentially, and there are a lot of systems that can be used in either case, including deployable panels. They can be scaled to 1U or 2U or such for Fox Plus. So there's a lot of trade back and forth. These aren't two entirely separate programs. So that is a good way to best use our resources and the combination of what comes from our volunteers. The Fox Plus status, there's one, obviously. At the beginning, they're going to go with Fox Plus A, as it's called now. That's probably similar to what we called Fox 1A or B, or pick a letter. Right now, the status up report is that we're pulling together information for a PDR, preliminary design review, which is the first look at the designs that you're coming together with for the initial run, and are they solid enough to proceed to an engineering model stage. The LTM, linear transponder module, which is what flies, it's a package we provide, and we call it LTM. But that same module is being used on Golf and Fox. And so they're in the process of being manufactured in a quantity to be able to provide enough for everyone to work with and to fly with Golf. And the ICR, which is the improved command receiver, is ready for assembly. More on that later. What we call the legacy IHU, which is the IHU from the Foxes that makes up the LTM, is being reviewed for updates of EOL parts. One of the things that we saw a lot of during Fox, and we're seeing even now as things progress with Golf, is that parts go end of life. And we will look at something, we will spec something, and we even started buying a lot of them in quantity. And we have to watch out for that, because one of the reasons the Fox 1 series came to a halt was that the parts were unavailable to make, for example, the receiver, and for so when was the receiver? It was the PSU. And you know, they're just sort of things that all of a sudden these parts are, you can't find them anymore, the transmitter too. So it would take a redesign, and the batteries, you know. So it would take a whole redesign to keep going with it. Well, the Fox Plus can pick up with that in mind, if you will, and be starting out with some better stuff. And we've placed an order with ISIS Space Engineering then for some engineering model components, the 1U space frame, and their EPS and their deployable antenna, which you may be somewhat familiar with. It's a cross dipole that extends kind of like a carpenter's tape out of on the top of the satellite. And they'll be working with that with the Fox Plus, plus 2 LTMs that are on hand that will be are being shared because of our distributed engineering. We have engineers everywhere, and that way it makes it easier to be working on something with more than one person. ASCENT, as I mentioned, is the Advanced Satellite Communications and Exploration of New Technology, an acronym for what was proposed in 2015 as a skunk works. And it is essentially just a playground or sandbox for engineers who have an idea, want to get together and try to develop something. As I mentioned, golf has a lot of stuff that came from that same sandbox. Unfortunately, at that time, the engineers came with it, and ASCENT went quiet for a while. We have a reactivated interest in it, and the ARDC grant, which we received to work on the open source space frame and deployable solar panels for golf, is currently being worked on with cable routing and getting ready to generate the initial prototype. So it's actually for golf tee, but it is an ASCENT project in that sense. And that deployable solar panel concept that was proposed is in the process of obtaining mounted cells for validation and beginning their hinge and cable concepts. Getting traction on the development of the multi-channel FM transponder. This is an idea that some engineers came up with, and you'll see more about that shortly. And starting the generation of a SSTV transmitter as an educational payload that I think you might talk about in your piece. Frank will talk about that a bit. And we're having some great progress on what we call SDR Plan B, which is the idea of an improvement. See, like I said, we fly in the Edison Golf Tee. We want to have our own. That's AMSAT. That's what we do. So there is work going on with that in order to have something that has a better footprint, more in line with what our avionics stack is typically like. And so there's a lot of really good stuff going on. Unfortunately, a lot of it is kind of behind the scenes because it's difficult, especially with distributed engineering when we're all over the place. You know, everybody's somewhere and everybody's here and there, to even get a picture of yourself working. You know, it's kind of hard to take a selfie with a soldering iron going over here or something. So, oh, I think you meant the soldering iron. Okay. With more to come in ASCENT. The RTIHU version 1.2 is being laid out. Better design for it before it's even flown. Custom debug boards being designed, and you'll hear about that too. And the flash loader nearly complete as well. PACSAT is a great idea that's coming along, and Bill Reed is here to talk about that later at the table. Prototype transceiver boards ready. We've seen a packet software demonstration of it, and it's very cool. And a schematic for flight board processing. So ongoing identification of ELL replacements, including the AX5043 chips used on the RTIHU and PACSAT. Sorry, I got to speed it up a bit here. We need volunteers, can be covered here, and please do come by the table, but there are some specific tasks that we're looking for people. And with that, I wanted to get into a little part about how we do all this, and that is that over 50 years, AMSAT's been building satellites, and it's been just a few generations of dedicated volunteers who spend a lot of time doing this, come together for fun, which is what we essentially do, although it's not coming together quite so much, but and producing the satellites. So I have a video that I would like to show.
Hey everybody, my name's Tom Karnauskas, November 0 Uniform Whiskey, based in southern Minnesota. I'm pleased to have been active with AMSAT for about a year right now, and I have a mechanical engineering background, so my contribution to the development of Gulf satellites deals with the structure of one of the future satellites. So a significant part of the task involves working with all the electrical engineers when they're dealing with the physical design of their components, such as circuit boards. And truly amazed at the knowledge of the skill sets of the team, and glad to be have the ability to work on this project.
Hi, this is Rich Gopstein, KD2CQ. I'm a software engineer. My contributions are to the Golf T satellite, where I'm working on the AX5043 radio chip, which does the telemetry and some command and control, as well as the EDIS SDR module. In addition, I'm working on the ASCENT project on a new generation SDR project that we're going to build for future satellites.
Hi, I'm Hamish Söderson, W1ANT. My contribution to AMSAT has been writing a flash loader for a new onboard computer, the Radiation-Tolerant Internal Housekeeping Unit, or RTIHU. The flash loader takes control every time the onboard computer is started and can be used to load or update the actual flight software. Debugging low-level software like this is sometimes best done using an oscilloscope.
Hi, I'm Chris Grill, WB6CQA. While I'm an embedded engineer that will be working primarily on the Fox Plus project, my current contribution is to the Golf T team, where I'm working on laying out a debug adapter for the Golf T engineers to use while working on RT-IHU firmware.
Hi, I'm Burns Fisher, WB1FJ. My contribution to the Golf T satellite is writing software that will fly on that satellite. This software has multiple jobs: switching control from one main computer to another in case of failure, collecting data like temperature and voltage around the satellite and sending it to the ground as telemetry, not to mention receiving, authenticating, and executing commands from AMSAT ground stations. I've always wanted to work on spacecraft, and I'm getting a chance to do that with AMSAT.
Hello, my name is Carl Wick. November 3, Mike, India Mike. I'm a professor emeritus of the U.S. Naval Academy. I hold a Doctor of Science degree in computer engineering. My specialty is in embedded computers, both software, hardware, and sensors and actuators that go along with these kinds of systems. My current project for AMSAT is to characterize the radiation environment of the Golf T orbit so we can figure out what our expectations might be in the way of total dose of the electronics, and also things like soft errors that occur due to radiation. I've also done software development for ground stations and command and control for ground stations to the satellites. I've built some test and evaluation hardware, and also do some analysis from time to time.
My name is Andrew Robinson, KA3WDW, longtime amateur radio operator, but new to the AMSAT team. Recently started collaborating with Joseph on developing a FM crossband repeater that leverages SDR technologies to expand the capabilities of our CubeSat platforms. Really enjoy engaging the team and looking forward to tackling these difficult challenges.
Hi, I'm Joseph DeVerde, K0NMR, longtime practitioner of radio science, RF engineering, and scientific instrumentation. I'm a very recent addition to AMSAT's design and development teams. While coming up to speed on all the many details I've begun to examine with my new colleague, Andrew, the high-level design issues of the Golf T satellite targeted FM crossband repeater, or FMCBR for short, or CBR for shorter. This device is intended to provide simultaneous multiple communication channels for several concurrent satellite users. Traditionally, only one contact at a time could be made with a satellite repeater. The CBR will permit several at the same time, thereby increasing the access to a particular and precious satellite. It is a challenging project with a big payoff and a real pleasure to work with the rest of the talented team.
Good afternoon, everybody. My name is Frank, N1UW. I am the Vice President of Development for AMSAT, and we'll give this one try here. And if it doesn't work, we're just going to go on without it, okay? There we go. Okay. This will be a real quick introduction or repeat of what we're doing with the Youth Initiative. There's two reasons why we started this up a couple of years ago. Lost some ground due to COVID, unfortunately, but you know that's the world that we live in. The Youth Initiative actually has two purposes. One, obviously, is to introduce kids into the world of amateur satellites and amateur radio. The other thing that we're doing, the other reason for the Youth Initiative is, you know, the amateur radio community cannot afford the cost of flying in space anymore by itself. So we have to look for external funds from philanthropic organizations or corporations in the aerospace industry. And the best way to do that is to offer a program that is of socially worth redeeming value as opposed to just everybody working their Gridmaster award, right? So that's one of the reasons why we have the Youth Initiative, is to demonstrate what we're doing to promote STEM activities throughout the youth world. Okay, what we have developed is we have two different brands which we own the domains and trademark names for. KidSat for the kids in about 5th grade to 8th grade, something like that. And no teenager wants to be called a kid, so we have BuzzSat for the kids up in the high school and beyond age group. Now, one of the differences in this program from a lot of other approaches is that this is not an amateur radio licensing program. Okay, that is not our interest. If you walk into a virtual classroom and say, okay, who here is interested in amateur radio? It's like nothing. The kids don't even know what amateur radio is. They don't even know what radio is. They don't even know that this is a radio, okay? So what we're doing instead is we're going after the kids with interests that they already have, like climate change, pollution control, preservation of natural resources, a career in the military, broadcasting, space, science itself, all of this stuff. Kids with any scientific inclination at all, they already have an interest in this. So what we're doing is approaching them saying, okay, you have an interest in this. Let's show you how satellites in space help us improve our lives here on Earth, okay? So that's the message to the kids to get them interested. Amateur radio then becomes the laboratory, okay? Amateur radio is not the end game. It's the laboratory that we use in all of the experience and the hands-on activities. So what do we do? I mean, what are we actually offering? There are 4 different areas of activity. One obviously is going to be, and we're in development on these right now. We're ready to pull the trigger on a small scale in the 3rd or 4th quarter of this year. There's a series of online courses. These are not college level courses. These are not even full semester high school courses. Think kind of like a step up from a Boy Scout or Girl Scout marriage badge. Okay, there's some work involved, but we're not going to make them scientists. We're just trying to light the fire and get them interested in pursuing these areas by giving them some interesting activities that have some quick rewards and some reinforcement for doing that. So for all of those areas that I just mentioned, pollution control, climate change, broadcasting, so on and so forth, there's a curriculum track for them to follow. And again, using amateur radio as a laboratory. How does that work? One of the things that we will have is a fleet of ground stations, SDRs, located throughout the country, up to 210 of them actually. And it's not the usual SDR that you see. If you look up at the screen there, you see in the middle, there's a very tight front end on that where we're pointing them to the NOAA polar satellites, the ISS, and some of our own satellites that'll have STEM payloads on them that Jerry talked about. Okay, so they'll learn the orbital mechanics by learning how to track the satellites, predict them, then tune in the SDR and download the telemetry or the data, and then the curriculum that we have online shows them how to manage that and hopefully have some fun with that. Along with the SDRs is a fleet of what we call non-orbiting Earth science experiments, or NOSI. What this is an enhanced version of Alan's CubeSat simulator that you're going to see in a minute. Basically, what this does is add 5 different sensors in there for measurements of phenomena that are associated with climate change. Okay, everybody knows maybe what a Davis weather station is. Okay, for home weather station, this is like a climate change or global warming version of that. Now, this is also, and then finally, I want to talk about just a sentence what Jerry was talking about, the STEM-oriented payloads. We've got some initial plans for up to 4 of these. This is not a separate family of satellites. What we're talking about is educational payloads that'll fly on board the Fox Plus series of satellites that Jonathan Brandenburg is working on. So yeah, these are educationally oriented, but yeah, by the way, they do have amateur radio transponders or linear transverters on them too. So we have to have some fun too, okay? But kind of the point is the amateur radio is our reward for doing the right thing, okay? Not the end game in themselves. So, I'm sorry. One thing that did I do that? The one thing that is kind of unique about this approach too is this is not a school-based program. Okay, there's nothing wrong with the schools, but this is not a school-based program. Refer to this as a community-based program. So that if a school wants to pick this up, that's actually fine, but we're making the materials in the program directly available to the parents, the kids, community leaders such as Boy Scout or Girl Scout leaders or 4-H or whatever the case may be. This is open source. Anybody can use this. The way we're making our presence in each of the marketplaces is a partnership with local television stations. There's 210 different television markets in the United States. We've had good conversations with network management and some station management. They love the idea because what we do is key on the meteorologist at the television stations. Okay, it's usually the meteorologists that host the in-school relationships and so on and so forth. So this is a win-win situation. The television station has an opportunity to further engage with their audience, increase viewership. It's beneficial to us because it gives us a local presence, publicity that we can never afford to buy ourselves. Okay, so that in a nutshell, ladies and gentlemen, is the Youth Initiative right now. There's a lot of layers of details to that. Come by the booth. We'd be happy to talk about that. Alan, let's give them a real show with those CubeSat simulators. Okay, this is the fun stuff to watch.
Okay, so hi everybody. I'm Alan Johnston, KU2Y, and I'm AMSAT's Vice President for Educational Relations. I'm also an Associate Teaching Professor in Electrical Engineering at Villanova University. So if you stopped by the AMSAT booth this week, you will have seen the CubeSat simulator, and that's primarily what I'm going to talk about today, as it's the core of our current education outreach mission. So I'm going to talk about the CubeSat simulator. I'll mention the team that's put it together, and give an overview of what it's made of, how it works. We'll do a demo here, see if things actually work in person, and then talk about how you can get involved as well. So just want to thank the team that's worked with me on this over the years. There's been a lot of us that have contributed. I think only Jim McLaughlin, KI6ZUM, is that I've seen here this week. I don't think any of the other volunteers are here. He's hanging out at the HRO booth these days, so you can say hi to him over there. But anyway, thank you to all the volunteers. We wouldn't be where we are today without all of your efforts. So the CubeSat Sim, it's our core product that we have that we use for outreach to universities, high schools, and basically anywhere that someone wants to do a demo of amateur radio satellites and show how satellites and radio communications works. We also hope in the future to use this as an outreach towards libraries, museums, and maker fairs. So going after sort of non-traditional ham radio groups and introducing them to amateur radio and satellites. So the CubeSat Sim, it's a low-cost satellite emulator. It basically does the same things as a real satellite, but it's designed for the classroom. Everything is designed to be low cost to build, and to demonstrate as many STEM, science, technology, engineering, math principles as we can. And as such, it's got working solar panels, rechargeable batteries, real sensors, and it transmits telemetry in the exact same format that real CubeSats do when they're on orbit. And it has a 3-board stack, including a Raspberry Pi. The current version of the simulator uses a Raspberry Pi Zero, and Pi Zeros have been very hard to find lately due to global supply chain issues. So we're actually working on a beta version that uses the Raspberry Pi Pico, and I'll talk about that in a bit. And it uses the same software, the same ground station as our real CubeSats. So some of you, I'm sure, are familiar with Fox2Lem, which is the excellent open source software that AMSAT has developed, and that's what we use to monitor the health of our orbiting CubeSats. And the CubeSat Sim basically generates identical radio signals that you decode with the same software. So you can use it to practice and train. And then if you just switch to basically an outdoor antenna and then tune in at the time your prediction program says, you can receive real satellite telemetry. So I'll just talk a bit about the version 2 beta. So it started off as just an effort to switch from the Raspberry Pi Zero to switch to the Pico, which is cheaper and more plentiful. But we've also used the opportunity to make it a little more like a real CubeSat. Real CubeSats run using a microcontroller rather than a full Unix processor, for example. And also, it's also a way to reduce our costs. And we also hope later to have the ability to do fully assembled boards. Because right now you pretty much need to assemble your own. You need to 3D print and solder. But in the future, we hope to have fully assembled CubeSat Sims. In terms of functionality, there's actually no new functionality. It's identical to the version 1. It's just done using different hardware and different software. The new version 2 has these blue boards, so you can tell right away which one it is. And we're currently still supporting V1, and we will continue to support the version 1 for quite a while, although in the future we may not add features to the version 1 software and hardware. So just a little bit about what is under the hood of the CubeSat Sim. So the main board has the Raspberry Pi Pico microcontroller and also some transmitter hardware. Unfortunately, once we went away from the Pi Zero, we weren't able to use the RPi TX library, which modulated the clock pin on the Raspberry Pi, and we used to generate all our RF. The upside is that our new hardware actually has more power. And if you remove the attenuator, you can actually get 500 milliwatts of power, which we found useful when we flew a version of this on a high altitude balloon a few weeks ago. We were able to transmit live slow scan TV images from our balloon, which was a lot of fun. So that's a plus for that. And it's also got temperature, pressure, humidity sensor, and a 3-axis accelerometer gyro. The solar board has the current and voltage sensors, so we monitor independently the current and the voltage of all the solar panels and the battery, so you can look at the power situation. And then finally, the battery board, we use low-cost nickel metal hydride batteries. They're also very safe batteries for students who are building it. If you short out a nickel metal hydride battery, it doesn't turn into a flamethrower, for example, which is a plus. And the ground station for the CubeSat Sim, it's just the same software. If you already do satellite telemetry, it's the same software that you're using today. And in particular, we've built it all into the excellent Fox in the Box program developed by Burns Fisher. And basically, Fox in the Box is a Raspberry Pi image that has all of the software that you might need for satellite telemetry preloaded with scripts to run them and configure them, and you just switch between them nicely. So you get things like Fox Telem, Direwolf, QSSTV, OpenWebRx, Cubic SDR, gpredict, and others. And they all work together nicely. And if any of you have ever used SDR software, in general, they do not work together nicely. As soon as you run one, it crashes the other. So anyway, it's nice for this. You can also just manually install the same software on your Mac or Windows PC and do that as well. So the CubeSat Sim, it transmits in 5 different telemetry modes covering a whole spectrum of different satellites. So some of them are the same as the ones we use in our Fox CubeSats. Others include APRS and also slow scan TV. And you can do an awful lot with CubeSat telemetry, with satellite telemetry. You can really learn a lot about this. And we have a team that's developing some materials and experiments for students to use for this. So you'll be seeing those coming soon. And one way to do it is you can take your CubeSat Sim, put it on a turntable, put a lamp in front of it, and spin it as if it's in space, and you generate very realistic satellite telemetry with that. The other way you can do it is that you can generate that telemetry in a simulated way. If you don't have this set up, then you can just generate it using realistic values, and from that you can interpret the telemetry. You can figure out is the CubeSat in eclipse or is it illuminated? What's the rotation rate? What's the axis of rotation? How well is the battery functioning? Is it charging or discharging? You can figure out all that status based on the telemetry. Okay, so I'm going to try a demo here. So this is a full CubeSat simulator. This was actually built by my freshman computer and electrical engineering students this semester. They did a pretty nice job on it, I think. This is the tape measure dipole antenna. Normally it would have solar panels on all sides, but it's we left them off to show it. But I'm going to try a demo here using this. These are the beta boards, the V2 boards. So anyway, demos always fail. So let's see what happens. So I have my ground station set up. So here is my grounds. Okay. Get that over there. Now I can't see it. Okay. So there's my ground station running. And it looks like we're transmitting. Probably missed the CWID here. Okay. So that is the lovely sound of binary phase shift keying telemetry. It's basically just noise. Let me just, I'm just going to power it up again here. So that way you can hear the telemetry as it boots up. And I'm going to turn on mirroring here. Okay, now I can see that. It's better. Okay, so this is Fox Telem software, and we should see the signal. There we go. There's the Morse code. Okay, and now we hear the BPSK, and it's actually not locking in here. Let's see if we can get a good eye signal here. There we go. That looks pretty good. It says we've got about 11 dB of signal to noise ratio, so that's pretty healthy. Now, if I go under here, I can look at the data here, and you can see things like the battery voltage, the solar panel voltages and currents, temperatures. And this is actually all simulated telemetry because, as you can see, there's no solar panels attached here. So it's recognizing the fact that I don't have any plugged in, and it's generating the telemetry here. Okay, I'm going to put this into another mode here. And unlike a real satellite, this has a push button on it. And I can change the mode based on the number of blinks here. 2 blinks, 3 blinks, and 4 blinks. So I release that now. So that should put it into slow scan TV mode. So I'm going to put my ground station here into slow scan TV. Got it. And we will see the image. So it's going to transmit a stored image, which it does first. And then after that, it transmits images from the camera. And it basically sends one every 30 seconds or so. Let's see if it gets going here. Oh, it's just an RTL SDR dongle. It's over there in the corner. I have my ground station plugged into the power. Oh, okay. Yeah, I have my Raspberry. No, I'm not running it here. Let's see. Well, that's interesting. I don't have any lights here. I think my CubeSat suffered a failure here. Okay, that proves it's a live demo. Okay, let's wrap it up here. Anyway, if you want to see more about the CubeSat simulator or ask questions, come to our booth. So thank you very much.